So when we first learn how to combine function is we find out the sum, difference, product, and quotient of functions. But here is this example asking the you have to reverse the product process. See, you're actually given a function px equal this, and then ask it to write explicit equations for two of the function f of x and g of x, so that the product of these two functions equals to the given one. So the one thing you have to be very careful. So of course you can just factor them and you get two factors. Then you can just name each one being the each one being fx and gx. Of course the product is going to be the given one. And notice that the two new functions fx and gx, they both have a domain like all real numbers, and that's exactly same as the original function. And then the second one, the b is asking you to, so you're given the q x equals x minus 4. You can see the domain is also all real numbers. So then you have to be very careful after you find out fx and the gx. So their domain is supposed to be all real numbers as well. But notice the gx is on the denominator, right? To make the x be all the real numbers. So you have to avoid that any x should not cause the gx equals 0, right? That's you have to be very careful. Of course, we find a way is name the gx equals x squared plus 2. And of course, it doesn't have to be 2. It can be any number as long as it's not 0. So you can see that x squared is always positive, so it plus another positive number, so it can never be 0. So that's why we choose the gx first, just because we want to make the gx has a domain of x be all the real number. So of course that's one of the example. And then since you got the gx, so if you put the gx here, qx is just gonna be the original one. So you can find out that fx is actually a product of qx and gx. So that's why. So we just find out this fx by multiply this, and eventually you put them together like this. And then finally you can examine. Now you get fx on the top. It has a domain of all real numbers. And also you have a gx on the denominator, also has a domain of all real numbers. So that's make it the quotient also have a domain of all real numbers.